Okay, so I've got to use two of these at the same time, so I'm probably going to get a bit confused. Actually, first of all, is anybody here mainframers? Kind of ish. You got a mainframe?
We have them.
You have them. Has anybody got a mainframe account or used the mainframe before? No? Apart from you, Alan, obviously. Seeing that you've been on the course. Okay, perfect, right. Good, so hopefully some people will learn some stuff here. What we're going to do is we'll just go through the first little bit, and then we're going to dim the lights. Okay?
You want me to?
Does that start working?
I'll do them.
Your thing doesn't work, Alan.
Turn it on.
Is it turned on? Don't be cheeky. Did you break the thing, did you?
Nope. Sound. It's doing something with volume.
Right, just press the button then.
Let's do it.
I think it's run out. Are we okay? Right, good. Okay, so what's this talk all about? So it's the big box of mysteries, right? The only reason I put in big box of mysteries is because I wanted to get IBM in there, alright? So it's this big black box that nobody really knows much about. A lot of people actually say to me, is this still a thing? Isn't this legacy? Nobody uses it anymore? Yes, it is. So it's mostly about the IBM Z series, which are really up-to-date beasts. There's some security concepts and concerns, a bit regarding them, and I'm also going to be talking about the Hercules MVS emulator, which is the emulator that you can use and download and do a bit of practice on your own mainframe. Right, obviously, because it's a hacking talk, we're going to talk about breaking into these things. And as it says at the bottom, they are still used. It would be easier if I got this working, actually. Give me 2 seconds. It's on. Yay, it's working now. Right? You want to go back?
Yeah.
It is there. Okay, yeah. So, for anybody who's wondering how old I am, I thought I'd wear a t-shirt that says Best of 1970, right? So, yes, I'm generally this is a tape as well, right? It's a cassette tape. I am the generation who says, let's tape this, it looks really good, right? So basically, parents' generation, really, to be honest. So, I'm the security training and infrastructure manager at a big bank. I started in 1992 after I left college, and I've been a pen tester since 1999. That's not 1892, it's 1992. Obviously, I teach and mentor ethical hacking at basically where we work, NatWest, let everybody know. And I'm also a fencing coach, and probably most importantly, I own an IBM Model M keyboard. Does anybody know what a Model M keyboard is? It's an amazing, lovely keyboard that's very clicky. Costs a lot of money these days. Alright? But it's what I used when I was young. Hubert, over to you. We're gonna just dim the lights as well so you can see everything that's going on.
Yeah, Hubert, Januzewski, I graduated here.
There you are. See, that's a vast improvement already.
Graduated here last year, joined NatWest. Younger and cooler, don't care.
No.
I hope everyone can see that. The last line is a bit of a slander. We'll get there.
That's cool. And your favourite food is?
Not strawberries, pasta and cream.
Cool. Alright, okay, just moving on. So, first of all, do you want to dim the lights so nobody can see me anymore, which is much better?
How do you do that?
Top one, cinema.
Cinema.
See, I've learned how to use touch screens in my old age. Right, so first of all, we are not mainframers, we are pen testers who are researching mainframe security. Okay? So we're going to give you a little bit of history of mainframes, but we're only going to go so far back, and you will figure, I will tell you the reason for that. It will become clear later on, only as far back as the IBM 370 MVS. Right? It's not easy to find an awful lot of information out there. I really only started looking into mainframes in 2023 due to the fact that we needed some mainframe pen testing done. There's not a lot of people out there doing it, so we thought, hey, we can do this ourselves. And starting to research this was pretty tricky. So I have to say, we're not here representing our employer. So we have to basically say that. Okay, so a little bit of history time. I was going to ask people to shout out if they knew. So here's our IBM 370 model up here. If I had the pointer, I would point at it, but it's the big box in the middle with the knobs and buttons and stuff, not the printer bit at the side. Okay, so IBM 370, any idea when that came out? 1970. Processor speed, any idea? Have a guess. It's in megahertz.
Like 3.
3. Close, 12.5. Pretty fast though. Storage. Now, storage on a mainframe is confusing because they didn't want to call it memory because they thought that people would think that the memory they would lose the memory or something like that, so they wanted to call it storage. How much storage? So, i.e. memory. Nearly 96k. 96k was the bottom model. 128k was the kind of top model, but it could go up to 16 megabytes. But nobody could afford that amount of memory back then. Hard disk capacity. Hard disks are called DASD because they don't really use the word storage, so that you use something else. So hard disk capacity, what do you think? In megabytes.
200.
Nearly 400. That was a good guess, but that was a lot. That was a lot, and that cost you a lot of money.
Excuse me, were those the ones you can actually extract the platters out?
Yes.
You platters in?
Yes. And you really had to extend out. First you need a room for that. Right, so the operating systems were MVS and DOS, and I'll go into that in a little minute. Okay, any idea of the cost?
5 million.
Oh, that's pretty good actually. My parents' house. Oh, you've told them now. My parents' house back in 1970 was £2,500 that they bought it for as a one-bedroom flat. I bet you guys wish it was still like that. These cost 700,000. That was the starter price, up to 1.5 million, and that was back in 1970. So really, you're talking £5 million. So you're right, pretty much right there. Security, there was no security. Okay, until 1976. Okay, my first PC back in 1989 was 8 megahertz with 640k and 20 megabytes of RAM, right? So it was pretty advanced for something that was 20 years earlier, alright? Next. Okay, so we're talking about mainframes, right? Mainframes are still very much a thing. So the IBM Z16, which just came out in 2022, has a processor speed, multiple processors, obviously up to 200 processors run at 5 gigahertz. Each processor has an AI chip on top of it, and it's 32 megabytes of cache per processor as well. Hard storage, memory, 40 terabytes up to. Hard disk capacity, 500 petabytes. It runs almost any operating system you want to mention. ZOS, Unix, ZOS is the ZOS, right? And my first mainframe, which I got last year, is a Hercules MVS 370, which I just downloaded, which is great. So why are we talking about mainframes? Basically, transaction processing, they're fast and built for I/O. They always have been. Still, 90% of the world's debit and credit card transactions go through mainframes. So if you bought anything today, with your phone, with your credit card, anything, that is going to go through a mainframe. And there's more credit card transactions than there are Google searches done on a daily basis. The uptime is often measured in decades, right? We're talking like 20, 30 years some mainframes are up for. And it's backward compatible, way backward compatible. So basically you can drop a COBOL program from 1970 onto a modern mainframe and it will run. It doesn't need any emulation. That can be a bit of a problem and a vulnerability. And the reason for that is when you find something in the COBOL program that's wrong, you want to talk to the developer, he's retired or died, as it happens, unfortunately. So whereas these used government and public sector for data handling, massive amounts of data, telecoms, billing, call data management, and because the uptime is so good, we have scalability and reliability, which is good for HIPAA compliance and things. So healthcare providers also use it. Some of the key terminology. Alright. MVS, multiple virtual storage, that is the operating system of the mainframe. TSO, time sharing options, is the equivalent of your bash or your Windows command line or whatever you want to say. But TSO, time sharing options, is called that because multitasking was an add-on that would cost you slightly more money, well, quite a lot more money. Everybody's probably heard of RACF, which is the Resource Access Control Facility. That does an awful lot more than just user IDs and passwords. Okay, it controls all the transactions. It controls every file on the system and allows access or not. So don't press it yet. So the database was DES. When do you think it changed over to AES, higher level encryption?
2018.
Nearly.
2019?
2016. Is it implemented? Is AES implemented on most mainframes now? No, probably not. Right. Okay, so another thing we'll talk about is Customer Information Control System, or CICS. That is really the web front end to the mainframe, although you'll see a green screen. A lot of the applications that run on it are running in CICS. As I said, storage is memory. We've got direct access storage device, which is DASD, we call that. We don't boot a mainframe, we actually IPL the mainframe. Okay, initial program load. Data sets are files and directories. Okay, so we've got physical sequential, which is a file, and we've got a partitioned data set, which is a directory. And any files, I'm just going to use that word, files that sit inside directories are called members, and they get catalogued. Okay? And people think, well, why is it that they're not changing to be the same as using files and directories? Well, they were there first, right? So why should they? ISPF, Interactive System Productivity Facility, that's the menu system. We call it ISPF. I can never remember what it means. Okay, so special is the root equivalent. It is not root, but it's a root equivalent. It's the equivalent of being in the sudoers group. And finally, we have a terminal. That's an IBM 370 keyboard. IBM Model M keyboard there. Terminals, once upon a time, and this is important for later on in the talk, they were all actually attached either by coax cable or by modem, right? And there was no way to tamper with them. Okay, languages. PL1, which means Programming Language 1, which was made by IBM, is for lots of stuff. COBOL is still used a lot, right? That's for front-end CICS applications. Assembler is used because it's fast and has access to the hardware underneath. We also use reg scripting, and one of the most important things is job control language, right? And the job control language relates to the job entry system. So a lot of things on a mainframe are batch-driven, right? So you use job control language, which used to be once upon a time punch cards, right? Which would go in a card reader and be fed in and come out. But now they are still JCLs, which go into the job entry system. And as you can see at top, point on it worked, Alan, it would be great. We have a job statement at the very top, which says this is what it is. Basically, the exec statement, which is a program equals sort, and then below the dataset definition statement, which says this is what the output is going to be, right? And lots of other languages work on this as well. So some security issues. Some are out there on the internet. So surprisingly, so this was one that was found out on the internet, and there's basically hundreds sitting out there on the internet. I think another one I saw was Egypt Air. So that's not ideal. Applications can be old, right, and built before security was even a thought. Man-in-the-middle attacks can be something that work against Telnet and FTP and old protocols. Very, very simple stuff. The RACF database can have weak passwords. If Anybody knows about LM hashing, LAN manager hashing, that originally came from, which is used in Windows, that originally came from IBM LAN manager, and the passwords are currently, and still are, 8 characters long max, uppercase, and those are the characters you can use there, right? So if you combine that with DES, it doesn't take long to crack a database. Security issues are rarely mentioned as well. IBM don't like telling anybody there are any security issues. So if anything is found, they keep it quiet and then fix it in the background. So suddenly you find that your Nmap scripts don't work the next iteration. Luckily we've got Hubert here to fix Nmap scripts and make them work. So default credentials can still be in there. The main user on IBM mainframe is IBM user with the password of sys1. Right, APF libraries, a bit more complicated. You could probably see that as something like GTF opens. Right, so the APF library, which is the authorized program facility, if you can attach code to any of the libraries in there or any of the documents in there and execute that code, it will execute with special rights. Batch tasks can often have excessive access. It's like anything else that you might see on a Unix system, etc. They still have the same potential misconfiguration. And surrogate authority. This is where one user can't execute a command, but there is a surrogate user, such as root, who can be used to execute that command. And if the user if that user doesn't have any authentication, then you can execute at special system level. Difficult to research, but there are options. I found it quite difficult to start looking into this sort of stuff initially. Right, so let's have a quick tour. So, yeah, hit that, and then we'll need to hit Alt F4 at the end of it. So, just a quick tour here. So obviously there's a Nmap search. Sorry, an Nmap scan, and we've opened port 3270. So port 3270 is the standard telnet sort of port. They still use telnet, but it's a kind of an advanced version of telnet you use. So X3270, this is MVS-CE, so this is basically a completely free version of the mainframe. It's really easy to install. You just get the Docker system, go find it, and off we go. So just logged in, and instead of a dollar prompt, you get a let ready prompt. So really simple command. Listcat is the equivalent of dir or ls. We can list users. So as you can see, we're user IBM user. So although you might think this is a bit scary, actually it's just a list of different commands that work. Right? rvary is very important. You'll see that later on in one of Hubert's demonstrations, and he'll explain what that is. And you can create a text file. Who thought? So we'll create edit kevin2.txt, and it's just simple as this is a text file. Right? There's other ways to do it. And we just press return, edit, save that, end. And so now you probably get an understanding of where Y came from. It was here first. And we'll have a look at listcat again just to show that kevin2.txt actually does exist now. So, ISPF, which I can't remember what it means already. That is the menu system. As you can see, this is maybe something that if you've ever looked for images of mainframes on the internet, this sort of thing you'll see. You can create files, you can look at output, you can do anything you want through ISPF, really. You can do some auditing and other things as well. But the most important thing probably is to be able to look at files, understand what they do, execute files, and we'll see all that sort of stuff when Hubert does his presentation, part of the presentation. So as you can see, we just go in, it's just a standard sort of directory structure, can have a look at these things. The important thing here is you hit F3. You don't hit escape, otherwise you hang the system. Is that somebody yawning in the background here?
Yeah. Sorry.
I'll let you off. Okay, so we can also send a broadcast message to anybody as well. Send hello from Kev. to the name of a user, and they can look at it. You can send it now, or you can send it for log-on. So obviously, it's important
You can zoom in on the
broadcast messages such as "Thanks for logging on. Please log off," stuff like that. I think I fell asleep at that point. Next thing, we can add a user. So, I mean, if you look at Linux, you just add a user in the same sort of way. This is just a slightly different format. Okay. But it works well. What I'm trying to say basically is mainframes aren't that scary. Getting your hands on one can be very difficult, and we're lucky where we work because we've got a large virtual machine that we've been set up, because all these things can be VMs, right? As long as you're running on a mainframe piece of kit. But also importantly, you can just download this. This version that I'm running here is completely free. It takes 5 minutes to install. It just works. Somebody else yawning. This is unbelievable. Don't worry, we get to the hacking bit in like 5 minutes. I think that's us, isn't it? Yeah, okay, Kix. Last thing. This is what Kix looks like. Usually it's CICS, but IBM, who created Kix in 1968, refused to release the source code or let anybody use it. So the good old internet created a free version of Kix that works. And as you can see, you can just run applications. It'll still run COBOL applications. It'll run other Kix applications, etc. The only problem with this system is it can only address 16 megabytes of RAM at the most, but that is plenty to run tons of stuff.
You have Alt F4.
Okay, Alt F4, yeah.
Alright.
Okay, I think there's one more slide, so you need to go next. Hey, it's Hubert. I get a rest now. Not arrested, arrest.
So hopefully you're not asleep, at least not all of you. The cat's introduction. And now we'll get into some of the more interesting things, how to actually test a mainframe, how to actually try to hack a mainframe.
Seriously?
Yeah. So most of the tools you'll probably have heard of, if you know them well, maybe not, so probably not. But MAP is one that you hopefully all are familiar with. You can obviously port scan it to find out what services are available, and some of the scripts, there's 10-ish scripts written specifically for the mainframe to enumerate it. The interesting ones are pretty much TSO and DB2 DAS, all of the ones that have Kix in them. We can enumerate the users that are actually on the mainframe, on the Kix, and also just plenty of other information that we don't really have time to get into. John the Ripper, again, as mentioned, the Racket database is mainly going to be DAS, and with Racket to John, we can use John to crack them. Hydra, as some of the services on our mainframe are still standard, like FTP. We can brute force them with Hydra, we'll see that soon. Wireshark, where it's not default, it does support EPSODEC, we'll explain what that is a little later, and it does understand the TN3270 protocol that it's widely used. Ethercap, again, man-in-the-middle can be used against the TN3270 protocol if anyone logs in and you're listening. It's not by default protected, it's just plain text. Again, surprisingly, Metasploit does make an appearance, although it only has like maybe one or two payloads and like one exploit that actually works. And it's worth a mention, it's kind of surprising. Didn't expect that to happen. And again, FTP is that you can just FTP into a mainframe with the regular client. Files that might also work, who knows. Hack3270 is sort of like the perp suite, quote unquote, of the Kix green screen applications. We'll see that in just a little bit. And again, wherever there is scripting, we can make scripts for nefarious purposes. So, EPSODEC is sort of the precursor to ASCII, and although IBM did help develop ASCII, by the time it was finished and out, they have already shipped a few mainframes that used EPSODEC. There's a few differences between them. I think like ASCII is like 7 bits, F-statements are 8. It's just a different style of encoding. And they decided, we'll just stick with it. And they still do, and it's still annoying. But it doesn't really stop us from just recording a little bit of the traffic with, for example, T-Shark in port 23, waiting for someone to log into TSO or just logging in ourselves. But then just opening that pickup in Wireshark. And again, it's not ASCII, so show data as ASCII doesn't really do it justice. It's not really readable. But as soon as we switch it to EPSIDEC, you can clearly see that it's not really encrypted. You can read everything that's happening on there. And the keen-eyed might see, after enter current password, is suspicious 4321. That is the password. And now we have a few interesting, hopeful demos.
It's coming. There you are.
Okay, so we'll start the first one by just mapping. Maybe you can see whatever interesting or not interesting services will pop up there. Do a little bit deeper dive with a second scan. But the more interesting thing that's going to happen in a second is that we run out of the previously mentioned nmap scripts, the TSO enum, that will pretty much brute force what available users we have on the mainframe from the file that we give it. The way it works is somewhat reminiscent of how web apps might do it. You simply get a different error message if you try to log in with a valid user or with a user that doesn't have access or doesn't exist. Based on that, we can just interpret the screens returned from TM3270 and give a decision. Hey, does that user exist? Does that user not exist? It should be pretty simple. Just need to provide the list of users. So now we have a list. Let's try to break into one of those users. As I previously mentioned, there are plenty of services that are more normal on the mainframe as well. Plenty of those accounts will be crossing over. So plenty of TSO users will have the same credentials and access to FTP. FTP credentials might work in TSO. So let's give it a shot and try to just break into the admin1.2 account that we found on TSO using FTP. We can just do Hydra to make it fast, efficient, and more reliable than trying to do it over TSO. So again, all of these are test accounts we have made specifically for this demonstration, and they all have very weak passwords we made specifically for this presentation, so it really shouldn't take a long time. Yep. And just to verify, we can try logging in with TSO to confirm that these accounts do in fact cross over, and we did in fact just get some account. However, one account is not really a lot. Can't really say we hacked the mainframe if we brute forced FTP, or technically do. So let's go for something bigger. What we will do first is some other recurrences that we're looking around the mainframe list. We'll use the list user command Kev mentioned to sort of list what privileges we might have, see what we can do, and then we'll use rberry, which is that very interesting command. It lets us know where the RACF database and the backup of the RACF database are. And again, RACF database is the most important file security was. It has all the user IDs, all the password hashes, all of the security policies and settings. What we can do now is upload a little simple job definition in JCL. What that job is going to do is simply copy the RACF database from the sys1 catalog that we don't probably have much access to over FTP to somewhere where we can just simply download that database. And again, because it is probably going to be guess, we will have a good chance of cracking. As you can see, we can use ISPF, and the option is 6 on the ISPF, and you can then use the X3270 to transfer a file from a Linux system. It's not the most comfortable, it's a little clunky, type in different path, and make sure you have the right file, the right format, blah blah blah. But it's definitely doable. For smaller files, you might be able to simply go with just copying and pasting it into the 3270 terminal. This file is a little too long because it's a little more complicated and it's simply not worth it. So after the file is transferred, we can open it up, edit it, what we need to do is ensure that the name of the datasets, the record database, and the new dataset we want to be copied to place there and the same. The first thing we're going to do is delete whatever the dataset we want the new copy to be, just to make sure it's empty, in case for some reason someone had a file named ttoi.copyof.racfdb. Next, we're going to get the file in, get the file into the actual original Racket database, and we're going to place it into the same copy file. So after we save and submit this JCL, what the job entry system will do is pretty much going to parse it and say, okay, I need to set up these environment variables on these files, these datasets for input, these datasets for output, these executables. I need to do this, and that. It's a very neat way of doing jobs. And again, just save the file and
I'm getting there.
Okay. So using the top one, we save the file, and now we submit it the same exact way. You just type in submit. You should get a little confirmation in red there. Hey, your job has been submitted. Please wait a second. Yep. That will wait similar too, because again, it needs to parse the entire JCL and then actually do the thing, copy the Racket database. And it's not really a small file on our system, it's like a few hundred megabytes. So it should only take a few seconds. And when we execute, we get a little confirmation at the top there, pretty much says, hey, the job's completed, good job, your JCL was okay, everything was fine. Now, after it's all done, you can log off from TSO, log into FTP, so exact same credentials still, and download our database. One important thing to note when using FTP though is, especially for something like that, is you need to switch it to binary mode. Simply after logging in, you'll have to just type in binary, just do it. If you don't, then it's probably going to either mess up the download, or it's just going to not download it at all. It's going to complain. But we logged in, binary, and now we can just get a copy of RockFDB. As you can see, we are already in the working directory with TTOI. Again, it's going to take a second or two. It's a very big file. So after we have the file, we'll simply run rackf2job, get it in a format that can crack rather easily, and start cracking. But as for why we want to crack it, well, we have one account which might not have special attributes or auditor attributes that would give it special privileges with permissions. And we want to fix that. We want to get accounts that have all the permissions. Simple privilege escalation. That's good enough of a reason, I think. Again, we have the file, which is run job. Again, we will have a file that has the passwords that we know are there. These are test accounts, we only track them. Although theoretically, this file we just done does have plenty of other accounts that we actually use on our mainframe. We just don't really want to show them to you. And just in a few seconds, we should be able to see some password up, and you can log in and confirm, yeah, these are actual accounts. Let's call it that privileges. And another thing is that if we have a valid account on a mainframe, which is also a valid account on another mainframe that's connected within the system, we might be able to use network job entry things to submit jobs to another mainframe. This will let us sort of spread our influence somewhere else. But of course, to do that, we will need to know what accounts are valid and we get access to them. So, if we crack a couple of accounts, we just try logging in, we can see that 0012 is still the password for admin12. And we have a new account. One thing to note here, I don't know how visible it will be on the projection, but it's going, after we log in, it's going to complain whenever that the password has expired. That is pretty much because it's a test account and we've not really logged into it before. So a third little demo that we have now, this is sort of interesting. The short is that even on the mainframe or ZOS system, not necessarily constrained to the TSO prompt. Because if we log in to TSO as usual, without a ISPF, we get the ready prompt. And we issue the onvs command. You will be dropped into a more familiar looking Unix prompt. It's pretty much going to be the /bash, this is /bin/sh equivalent. And all our favorite commands, UMI, ID, uname, all those will work. And that on its own is pretty cool. What is cooler than having a Unix shell on a mainframe is having a remote Unix shell on a mainframe. So that's what we're going to do. We're going to go back into ISPF, upload another file the same exact way, although this one is going to be a Rex script. So again, when I mentioned wherever there's scripting, we can use it. We're going to do just that, to upload a script and run it. It's not going to be quite that reverse shell. It's going to be a bind shell, but we'll run it with simple execute, ex for short. Provide the name, provide the proof port number. We should be able to simply netcat into it, as with any other shell. 39,999. It doesn't necessarily need that high, I believe, but it's always good to have a high port. And we should be able to simply use all of the same commands, UMI, ID, uname. Yep, that's
Seconds. No, getting there.
So, about Kex. Kev has mentioned Kex is a customer information control system. It's pretty much the web application code of the mainframe. In this instance, we'll be looking at the green screen version, so these don't have like actual modern web application front ends attached to them. These will only be communicating through the TM3270. They're still used to serve applications over a network, but again over TM3270, and they can be written in most languages you can imagine. COBOL, Java, that's whatever Kex can handle running IT. The important thing to understand now is how they work. The server will send a screen that, as the green screen implies, the screen will be sent to you. You will be able to update some of the fields on that screen.
Sorry.
So this is for an example screen. You might be able to update some of the fields on it, for example, the account number. You can simply type it in, then you can press enter, or whatever other defined key, and that will be sent back to the server with our updates. Although we can only update unprotected fields, such below the account number, or probably the account number text itself, are likely to be protected fields. This is a very simple protection, you simply cannot type there. That's it. There might be some hidden fields. Hidden fields are what the name suggests. They're hidden. It's like you opening a Word document with white background, just typing in white font. Text is there, but you cannot see it. One important thing to note about those protections, though, and what makes the next demo kind of interesting, is that they're client-side only. So even though you're not supposed to be able to edit the protected fields, you might find a way to do that. Maybe you're not supposed to see the hidden fields, you might find a way to do that. So for this demo, we're going to use the open source version of Kex that Kev has shown out. It's spelled with Ks. And we're going to run that on the Hercules emulator, which means that after that, if you, for some reason, really bored suddenly, just spin one up yourself and give it a go. So as mentioned, we'll be using the Hub 3270, the quote-unquote web sweeper, OWASP Zap for the green screen applications. The way it works is, as pretty much any proxy, on the command line, we supply it with a project file, the IP address of the mainframe, and a port for it to connect to, and then it will create a local listener that you yourself can connect to with your terminal. Yep, you can see a little window at the top, waiting for connection. You're connecting to it and start. The important thing to note here is, again, this is the application that we're going to be using for this is the DVCA, the down vulnerable kits application, which means that it's intentionally very vulnerable, intentionally very weakly coded. And you can have some fun with it. If you have done anything with web applications, which I hope you did, then you might see the analogy to the downfall of a web application. It's sort of in the same vein. So, yeah, you can see it. Then the Kix application. This specific one is going to be called Mel Scouter. It's going to have a simple office supply purchase type application. And again, even though we have hacking functionality running here, before we start doing anything malicious, let's just have a little look around. One thing to note is, again, F keys, the PF keys has the mark on the right that will be used quite a lot. So first menu, office supply price list. I wonder what can be there. It's going to be a simple screen with the IDs of things that you can buy. Zero. Names, prices, printer paper, you can just type Y, hit enter, and purchase printer paper. Amazing. Let's see, but there's also other things. Again, we need to use the F keys to run. The DOM packing on is a little expensive, and the comment says, do not buy, but we're hackers, so let's try it anyway. Can we do it? Answer is that we can. We get a little denied written there in the corner. And there's plenty of other stuff. 22K gold MacBook Pro, a little expensive, kind of says over budget. Anything else? Maybe something cheaper you can also buy. That's a long pause, isn't it?
Yeah, I was just thinking about, would anybody actually want to buy a MacBook anyway? But that's just me, I'm biased.
Yeah, you should want to buy the ancient golden idol that's haunted. Well, let's take a look around other menus. Because even if we manage to order whatever MacBook or whatever Rose we can, it'll still be sent to Kev, and we don't really want that. I want it for myself, or anyone but Kev.
That's not my real address, by the way.
Maybe you can change. We do see the supervisor code, it pops up really quickly, it's in red. But maybe it's just for logging purposes, or maybe it's just as decoration. Maybe it's not actually necessary. You can try it. You can just try 1, 2, 3, 4. And unfortunately, no, it seems like it is actually necessary. It's something that we do need to type in. But I have an idea how we can get around that later. And again, the first screen is just going to be order history. I don't think it's going to be too interesting. It's just printer paper. But now comes the interesting part. So if you've fallen asleep, you can wake up now. You can enable Hub 3270. The first thing you'll immediately notice is that it shows and highlights the hidden fields that you've probably missed from this screen. 3 for future use, and one says 99, delayed order history. That might come in handy. Let's see the first screen again. Maybe there was something that we missed. And you can see a field. I don't know how visible it is, but it says purchasable and why. And if we scroll, then you can see that the things that we are not able to be purchased, for example, the down payment one, it says N. It's not purchasable. If we switch that, maybe there's a good chance we'll be able to buy it. But another interesting thing that happened to $70 again, it lets us write over protected fields. So we can not only get it, we can get it for $2. So even though the comment says do not buy, you can change the purchase rule, you can change the price, type in Y in the order supply, and hopefully, if the application does process it the way we think, we can purchase it. And again, this works for two reasons. Reason number one is that the protections offered by this protocol are on the client side, which means that with a tool like Hubert, we are able to get a MacBook for $8 by overwriting the price. But again, it also works because the developer might use the data on the screen that gets returned from us, sort of assuming that the protected fields will actually protect the data, which they don't. And okay, we have purchased a MacBook Pro, $8, that's a fair price, I think. Purchased Dom Perignon. But the issue here is that it's still going to be sent to Kev, and we still don't want that. Fortunately, Hubert 70 does have another useful thing that can help us with that. If you've used Burp Suite, it's sort of the equivalent of the Burp Intruder. It's in here, it's called Inject into Fields. Basically, the way it works is we can specify what file we want to use as sort of list of quote-unquote passwords. In this case, it's a code, which appears to be 4 digits, so there's not that many options. Next, we can use sort of a mask quote-unquote system to show Hubert essentially where exactly we want those brute force codes or passwords to go. And then we can start it. So again, file, we'll be able to select the file that comes with our downloadable text application, and will obviously contain the code. So again, you can underwrite the see that mask is now set to asterisk, which means we should go and fill the supervisor code fields with asterisk. You can change what the mask symbol is for in case there are already asterisks on the screen. Submitted that, and you can already see inject when the code is going, brute forcing. And after just a couple of seconds, we should hopefully see. You can see it both in the actual field and on the top. It says sending 1337, interesting code, valid pin enter, address updated, Kev is not getting our MacBook. We can confirm it once more, just to make sure we did, in fact, get a right code. 1337, valid pin enter. We go out of the menu and make sure, but it looks like it worked. And again, one last problem that we might have. We managed to order the things we should have. We managed to send to ourselves or pop the builder instead of Kev. But if we go into order history, anyone looking at that will go, oh, that's not right. What do you mean Dom Perignon was 1959 for $2? So we need to find a way to clear the history. But thankfully, which is right there on the main menu, the developer left us a hint. It's 99, we'll try it. So the 3 records from history, it's gone. And our last little tidbit here is, you've noticed hopefully, and I've reminded you hopefully, that we use the F keys to move around the application element. There's a good chance that a developer left, either intentionally or just forgot about some debug or secret functionality that's hidden behind hitting just one of those keys that are simply not documented anywhere. So with Hubert 70, we can inject key presses and just tell them, hey, try all of them. See if any of them does something weird. That's what we're gonna do. 7 keys. And congrats, we've accessed the secret area. Secret developer did in fact leave something that's secret but not too secret. And yeah, that is it for this demo, and I'll hand over to Kev follow a summary.
In summary, here we are. Right, hopefully that made sense. So, do you want to hit some keys? Cool. So, mainframes can be exploited, right? A lot of people go, "All right, this is something that you can't break into." It's not at all the case. It's all down to whether this configuration is there, whether old DES RACF databases are still implemented, and a lot of things don't change, right? Some of them sit out there exposed on the internet, obviously. There are testing tools, but Hubert and myself have had to adapt these testing tools to get them updated and make them work. They are there on GitHub though, and they are downloadable. There's lots of YouTube videos now. The ones that I was looking at was by a guy called Moshix, who will tell you almost everything about the actual MVS mainframe, and there's lots of videos that just show you around TSO and ISPF and all the things like that, which is really, really good. Soldier of Fortran, he is the guy who really does most of the pen testing. He created the original Nmap scripts, and he created DVCA, so his Tumblr account is very good to look at, and he also does lots of YouTube videos, DEFCON and stuff. The most important thing is TK4, TK5 Docker downloads. If you want to play about with this, right, and that's DVCA and the other stuff that we've just demonstrated, it's a free download, and honestly, it takes 5 minutes to get this installed. Right, GitHub has an awesome mainframe hacking group on there, and there's lots of stuff there if you want to learn more about hacking mainframes. And finally, learn.ibm.com. I wish I'd seen this before I'd already started. I was looking at YouTube videos. IBM have decided that finally they don't have to charge for all the training and things like that. So in the same sort of way as Hack the Box has got something that's not necessarily for security, but you can actually just go on to learn.ibm.com and you have mainframe labs, so you can play about with that. So it's not a case of you can't get hold of this stuff now. And that's it. So if anybody's got any questions, feel free to ask me or Hubert. I knew you were going to ask the question. Yeah.
Did you do it? One thing, have you looked at any of the stuff done by Big Endian Sports?
Yes, he's Phil Young's Soldier of Fortran mate.
Yeah.
Basically, so they've got they did have an evil mainframe hacking course
in the States,
which has now been taken over by Broadcom, and they called it the Ethical Hacking Course, and it's not out. So at the minute, we at NatWest are on a mainframe offensive security testing course, and it's the only one that's on the go in the world at the moment, unfortunately.
And the next question is, have IBM altered their approach to adversarial security testers? Because in the States, 7-8 years ago, they started to go after a lot of the cores, the processes, rather than the community and say, yes, problem software.
Yeah, absolutely. And this is actually, I think, a vulnerability in itself. The fact that nobody gets to know anything about anything that's actually come out that's new or a vulnerability or something you can work on, and therefore fix. So yeah, they've changed their opinion on that. And it's a bit weird because, I mean, if you think about X-Force, right, that's IBM, and they're one of the best sort of groups out there, been there for years and years. But they've got a completely different attitude towards mainframe security. Anything else?
Yeah, hi. Thanks for the talk. So, in terms of practical application, use the desk on the web apps, takes the number of frames. In terms of the current mainframes, is the techniques different? Have you actually tried it on?
Yes. 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 So, yeah, absolutely. So, DVCA is very vulnerable in the same sort of way as DVWA is really vulnerable, right? But if you have some application code from the 1970s, 1980s, etc., you don't necessarily have any transaction security against the back-end database. Okay, so some of this stuff will still work. The whole reason that it wouldn't have worked back in the 1970s is because we couldn't use a proxy, right? Because you had your coax cable straight to a terminal, and therefore you couldn't really tamper with it, whereas now we can tamper with these things because there's X3270, C3270 are the actual clients for it, and you can therefore proxy through the clients, right? So, yes, it can work, but it would depend on the security on the system, but all systems are not the same.
So is the principal attack vector on the client side?
Yes.
This is what we're saying, we're not seeing the rear end attack.
Yeah, because that's how the mainframe really works. That's why it's so fast at processing. It doesn't need to do one character at a time. It takes the whole screen as part of an application. You hit the return key and it sends the whole screen at once.
Yeah, thanks very much. Thanks.
Anything else?
How reasonable is patching and things like that? Your applications that you have.
Yeah, so there's a difference between patching really and fixing the application code. So patching these things, Z16, are absolutely up to date. So IBM does patch everything, right? That's why some of our Nmap scripts won't just work against version 2.5 of ZOS. The COBOL application code, it would depend if you would have to still change the application code to have every single transaction assessed against RACF, right? So RACF doesn't just do the database stuff for logging in. It will, every single transaction, every time you press return, if you've mucked about with it and RACF is properly implemented and the database backend is properly implemented, it'll go, no, wait a minute, you can't change that even though it's a hidden or unprotected field.
So sorry, stupid question. So why can't you just put RACF across all your apps?
Yes, we do.
Alright, sorry. So then
We do. But the thing is,
unhackable then.
we do, right? But it doesn't necessarily mean that every company does,
Okay.
right? And a lot of companies will just leave the database working. Then why should we change it, right? And by the way, the mainframe's in the bowels of the network. Therefore, why should we change it? Nobody's going to get to it anyway, which is not the case. And one of the important things here is we also do an awful lot of red teaming as well, and it's something the red teamers don't know about. I mean, I've got friends who lead red team for companies, and they don't know anything about mainframes. Amazing Active Directory, Unix, Linux, any of these sort of things. But as soon as I mention the mainframe, they go, we should be doing something about that. So it's something I think people should look into, because that's where the credit cards are. That's where all the transactions are done, really, at the end of the day. So, anything else?
So you think it's worth looking at bypass RACF then?
Yes, absolutely. Yes.
Am I remembering it correctly? So you know, it's 3 to 5 years ago that the password complexity went up to 8 characters from 7.
Yeah, it's the user ID is 7. The complexity of the password is 8 characters. So it's always been 8 characters, but you can now use passphrases and you can use multi-factor authentication in the latest versions of the last 2 or 3 iterations of ZOS. But it's quite late on for that sort of thing, because obviously the DES was defunct as a thing in Unix, quite a while ago. Anything else?
Well, I'm going to say on the passwords as well, but I guess that kind of answers it. But would you recommend an alternate regular access to use it instead of giving behind some?
Sorry, say that again. I can't quite hear you.
Instead of giving users direct access to see the terminal where they would log in, is it maybe a better idea to put a multi-factor whether it's say like a remote access application that they log in?
Yeah, and that's usually, absolutely, that's usually how it's used. You've usually got a web front end there now, so you've got kicks at the back end. There's a lot of stuff that, sort of credit card applications, things on your phone, there'll be kicks at the back end, you just won't know it. Right, so, and some of them, it does take multi-factor authentication and OID cards and other things like that as well.
Sorry, are they swinging PCI DSS?
PCI DSS compliance is very important, obviously. So yeah, especially because it's where the credit cards are all stored and things like that. And you can configure RACF and use set options. So that's just set RACF options to be really, really tight on every single transaction, right? And that's what I would expect from financial institutions.
Is that slow performance?
Yes, still high performance. I mean, if you look at the Z16 and the amount of I/O it's got, I mean, the amount of cache it's got on each individual processor, it's fast.
Yeah. Well, you also use emulation software for your mainframe.
Yes, we have VMs as well.
So,
yeah.
So is it worth actually going to eBay, buying old mainframes and trying that?
Good luck with that one. Well, first of all, the smallest mainframe you'll get is really the size of a fridge, right? And they still cost an absolute fortune. And if you want, so this is why the emulation, the Hercules emulator, is completely free. It does take you back to 1970, but I'm still able to run courses on that, right? If you want a ZOS license, it's going to cost you $5,000 a year per license. So that's why it was such a difficult thing to actually try and pen test.
Yeah, I was just curious. Thanks.
Yeah. Is our time up?
Yeah.
Okay, cool. Hope you enjoyed it anyway.